Good morning, class. Today we discussed Chapter 2, Units and Measurement. I hope that you understand previous topics. Today we discussed about significant figures. This topic is important because this topic is held in both physics as well as in chemistry. Rules for determining the number of significant figures, rules for rounding off a measurement, arithmetic operations with significant figures, numericals based on significant figures. So let's start with the first topic, significant figures. So first thing is what do you mean by significant figures? The significant figures are normally those digits in a measured quantity which are known reliably or about which we have confidence, which gives us a confidence in our measurement, plus one additional digit that is uncertain. For example, suppose the time period of a simple pendulum is 1.62 second. These digits 1 and 6 is reliable and certain, while the digit 2 is uncertain. So the time period has three significant figures, 1, 6 and 2. One more example. Suppose the length of an object is measured by you is 273.6 centimeter. So here there are four significant figures, 2, 7, 3 and 6, where 2, 7, 3 are the reliable and certain digits, while the 6 is uncertain digit. Because when anyone is measured the length of an object, the certain digit never change, but the digit which is uncertain is changed by person to person, is vary by person to person. Rules for determining the number of significant figures. There are so many rules. We have discussed few of them. First one, all non-zero digits are significant. Non-zero digit that means in which zero is not there. For example, 13.75. So how many significant figures are there? According to the rule, all non-zero digits are significant. So the significant figures are 4. 1, 3, 7 and 5. One more example I'll give you, that is 212. So how many significant figures are there? 3. 2, 1 and 2. All non-zero digits are significant. Second rule, all zeros between two non-zero digits are significant. That means 0 comes between non-zero digit. For example, 100.05. See, these three zeros are come between non-zero digits. So this is also count as a significant figures. So how many significant figures are there? 5. Is it clear? Good. Now the third rule. All zeros to the right of a non-zero digit but to the left of an understood decimal point are not significant. For example, 86,400. 86,400. How many significant figures are there? 3. 8, 6 and 4. These two zeros which is left to the non-zero digit are not count as a significant figure. Is it clear? And suppose that if the digit is come from a measurement, for the same example, 86,400 second. See, this digit comes from a measurement that you are measured the time. So how many significant figures are there? 5. 86400. Because when any digit which comes from a measurement, all figures are significant figures. Now next, all zeros to the right of a non-zero digit but to the left of a decimal point are significant figure. In the previous rule, no decimal, in that decimal point. Okay, so like 648.00. So how many significant figures are there? 5. Because these two zeros are left to the decimal point, so it is also count as a significant figure. Or you can say that 64,800 and you put the decimal over there, then these all digits are count as a significant figures. Next rule. All zeros to the right of a decimal point are significant. All zeros to the right of a decimal point but to the left of a non-zero digit are not significant. For example, 0.161. See, this 0 is to the, where it is lie? Left of a non-zero digit. There is a non-zero digit and it is lie left to that. So it is not count as a significant figure. And the significant figures are there 3. The last one, the number of significant figures does not depend on the system of unit. It does not depend on the system of unit. For example, 16.4 centimeter. Okay, it is converted in meter. You know that how centimeter is converted into meter? Divided by 100. So it becomes 0.164 meter. Now see, in centimeter how many significant figures are there? 3. In meter how many significant figures are there? 3. Now if you convert it into kilometer, then meter divided by 1000. So it becomes 0.000164 kilometer. So again the significant figures are the same. So significant figures does not depend on the system of units. Is it clear? Now, next, rules for rounding off a measurement. The first rule, if the digit to be dropped is smaller than 5, then the preceding digit is left unchanged. For example, the digit is 13.43. See, you want to rounding off that digit up to 3 places only. 1, 2 and 3. So that you have to drop that digit, and if the digit that you want to drop is smaller than 5, see what is the figure is 3 is smaller than 5, then the preceding digit, which is 4, is left unchanged. There is no change in the preceding digit if the digit that you want to drop is less than 5. Next rule, if the digit to be dropped is greater than 5, then the preceding digit is increased by 1. I'll give you the same example. 13.46. You have to rounding off the digit up to 3 places only, up to 3 significant figures only. So you have to drop that digit 6. Yes. So the preceding digit is increased by 1. It is just because that the digit that you want to drop is more than 5, is greater than 5. So the answer would be 13.5. Now the third rule, if the digit to be dropped is 5. Now the digit that you want to drop is exactly 5. Then what to do? If the digit is to be dropped is 5 followed by non-zero digit, then the preceding digit is increased by 1. Preceding digit is increased by 1. I'll give you one example. 12.653, and the question says that you have to rounding off up to 3 digit, means only this one. So you have to rounding off. Is it clear? Yes. Now the rule says if the digit to be dropped is 5, exactly 5, followed by non-zero digits, then the preceding digit is increased by 1. See, you have to rounding off these two, 5 and 3. So there is a 5 which is followed by this non-zero digit. So the preceding digit, which is 6, is increased by 1. So the answer would be 12.7. Is it clear? Good. Now the fourth rule, if the digit to be dropped is 5, again exactly 5, then the preceding digit is left unchanged if it is even. 12.65. Now this 5 is not followed by any non-zero digit. Okay, and if the drop digit is 5 and the preceding digit is even, then it is left unchanged. यहाँ पर किसी भी टाइप का कोई चेंज नहीं होगा. So the answer is 12.6. Now next, if the digit to be dropped is 5, again exactly 5, which is not followed by any non-zero digit, then the preceding digit is increased by 1 if it is odd. 12.35. The digit that you want to drop is exactly 5 and the preceding digit is odd, so it is increased by 1. So the answer is 12.4. Now next topic, arithmetic operations with significant figures. There are two operations that we discussed today. Significant figures in the sum or difference, addition or subtraction of two numbers. Then in addition or subtraction, the final result should be reported to the same number of decimal places as that of the original number with minimum number of decimal places. Suppose that you want to add 5.2 and another digit that you want to add is 6.83. Now the addition is 3, 8 and 2, 10, carried 1, 6 and 5, 11 and 1, 12. Okay, so the sum is 12.03. But in this addition, the minimum significant figures are 2 only. So the final result is also up to 1 decimal place. Up to 1 decimal place. That is the minimum number of decimal place in the given figure. So the answer is 12.0. Now the next, significant figures in the product or quotient of the two numbers, product or division of two numbers. In multiplication or division, the final result should be reported to the same number of significant figures as that of the original number with minimum number of significant figures that we discussed in the numerical section. For example number 1, in which you have to just find out that how many significant figures in the following questions. Examples are 2.000 meter, 5,100 kilogram, 0.050 centimeter. Then how many significant figures are there? We have discussed with the rules. You can just find the solution over there, which is given over there. If you are not satisfied with that, you can just ask me in WhatsApp group. Example number 2, rounding off the following numbers as indicated. I have already discussed the rules of rounding off. Here the solution is to be given. If you are satisfied with that, then okay. If you have any doubt, ask me. Now example number 3, add 7.21, 12.141 and 0.0028 and express the result to an appropriate number of significant figures. See the arithmetic operation. The minimum significant figures, the minimum decimal places. See, here only the 2, up to 2 decimal places. So the result should be up to 2 decimal places only. So add these 3 digits, 7.21, 12.141, 0.0028. So the sum is 19.3538. But after the decimal places 4 digits are there, but you have to rounding off up to 2 places only. So the corrected sum is 19.35. Here 7.21 has minimum number of decimal places, So the result is rounding off up to second place of decimal point. Example number 4. 5.74 gram of a substance occupies 1.2 centimeter cube. Express its density keeping significant figures in view. See, after the decimal places, how many? Only one. So we need to the result up to one decimal places only. Okay, now solution. Density. The formula for density is mass by volume. So put the value of mass and volume over there. Mass is 5.7 gram, 74 gram, and volume is 1.2 centimeter. Put these two values over there. Now just simply divide it. So our result become 4.783 gram per centimeter cube. Now rounding off up to the significant figures. So up to how many decimal places? 1. So the result is 4.8. Thank you, class.